point of story is to, well, get used to the equations of line and the other things associated to them. So the key part is to have the bunch of formulas that you don't have to memorize. You can just write them someplace that you can easily locate those formulas, so-called formula sheet. Did you ever try to create one? So maybe it's a good time right now to create so-called formula sheet. So this way you can actually start enjoying working with it. So we had a quiz last time. It was exercise number 40, but I changed the sign, I believe, right? So in exercise 40, I put something like that and ask you to do this for a quiz. In other words, there was a x minus y is equal to number 2. There was this little equation that I had to simplify a little bit. To simplify, I bring y over to the right side, so it'd be equal to x minus 2. So the reason I need to do this, I can write this with y on the left side and x minus 2 on the right side. It doesn't matter. You can switch around your y, either put it on the right or on the left side. It's still equal to x minus 2. So the key point why we do this is to be able to identify the slope, whatever is multiplied by x, and the intersection point with y-axis. So the formula actually plus b, right? So once I have y isolated on one side of the equation, then I can declare that slope is equal to number 1, whatever is multiplied by x, that's called the slope, and that's equal to number 1. And the y-axis intercept, the intersection of this line with the y-axis is a number -2. So these two things that I guess we were looking for in the exercise. And we used a standard form to produce the equation of a line. This form has y on one side and everything else on the other side. So I can produce various equations of line using these two formulas. So the one up here and the one with a slope and intercept. Well, it turns out that the more popular is equation on the left, in the upper left corner. For example, if you're trying to create equation of line in exercise, let's say number 29. So remember, I asked you for outside of class practice for homework to do a few problems from every section. So I just selected 29 just to show how one can practice, and this will be due when we have our midterm exam. And this is going to be in a couple of weeks, so pretty soon we're going to have our midterm exam because we're getting closer and closer to the middle of semester. So one should start doing homework because, well, I guess you don't want to be overwhelmed, right? And swamp in these homeworks. So I call point as a pair x1, y1, and I'm going to utilize the formula above to replace in it. So instead of y1, I have here number 5. Then this will be equal to, now instead of slope m, I'm going to be using number -7. And then I will multiply this by, in the parentheses, x subtract x1. So x1 is number +7, right? It's right here, +7. So I produced equation of line. They wanted, but definitely it needs to be simplified a little bit. So the form of that equation will have y on one side and everything else on the other side. That's the standard way to put the answer. So we have here -7x and +49, and there is still y -5 on the left side of this equation. So I just have to take that 5 and add it, right? Add it on both sides, just like that. So we have ourselves the answer for the exercise. It's y equals to -7x and +54. And again, the good thing about this textbook is that you have all of the answers right next to the exercise. But of course, it's not obvious how you get this particular answer because, well, looks like you need to do a little bit of work, and it's not obvious for this particular exercise. So when you do your homework, when you work outside of class, then you should get the work pictured and emailed to me, and that's, I guess, the way to go. So let's just practice, do some problems here, and let me continue with this. So I'm gonna be looking at the other things this section has for us. So let's check out the next page. And on the next page, they start to talk about lines being parallel or perpendicular. So you can see the exercise like number 43 here. And in this exercise 43, they say that lines are parallel. So why are they parallel? Well, I'd like to make a picture of these two lines in exercise 43. So we can see from the graph that indeed those two lines will look like a pair of parallel lines. So the first one is 3x plus 4. So that's the line with a y-axis intercept equal to what? 4, because it's added, right? Y-intercept. And the slope of that line is actually number 3. So the slope is 3. It's right here. And looks like we have a good start for graphing by simply placing number 4 someplace on the y-axis, because that's our y-axis intercept, right? So I got a line with a slope equal to 3, so that's somehow increasing line. You can actually see that's around and the rise, or just put some number in the equation of lines, the 1, and you get 7, and this way you can graph it. But the idea is that line has a positive slope 3. So the next equation here is 3x minus 7. So when you have a y is equal to 3x minus 7, then its y-axis intercept is going to be number -7. Y-intercept is -7, right? So I can see that -7 is someplace down below. I plotted there. And there be another line, turns out, with the same exact slope. So if slopes are the same, the lines are parallel. And if lines are parallel, then their slopes are the same. That's the message here. So you can actually see what other lines are parallel, like in a problem number 47, for example, where you see the line with slope 3 because it's 3x, but the second line I can modify a little bit and say divide by 2. So this way I'm going to have a y on the left side, which is the same as a divide 6 by 2 is 3x, right? And divide by 2 number -9. Well, when you say you can't divide it, well, I can put 9 over 2 or 4.5, something like that. So the point is that, again, the slopes are going to be the same, and that's what means that lines are parallel. So this, I guess, is pretty straightforward idea. Same slopes, lines parallel. There is one more observation that I want to make here. When those lines will be called perpendicular. So let me try exercise number 45 here, because we can see that lines there are perpendicular. So in that problem, we're going to have x plus y is equal to 2. Let me just copy those equations. And definitely I can write it with a y on the left side, and then I bring minus x here and plus 2. So that's my first equation. And the second equation is clearly given as a y is equal to x plus 5. I write it with the other color. Y is equal to x plus 5. So they give us two different equations, and they say that those lines will be perpendicular. Perpendicular. What does this mean? Well, they intersect each other at 90 degrees angle, and to get a better idea, I can figure out what the slope of the first line is, and looks like it's negative, and it's actually negative number 1 because we just have an x the way it is. And for the second line, looks like we have a slope equal to 1, right? Positive 1. So I can say that's my first slope, and that's my second slope because they're not the same, right? So people say that lines will be perpendicular. They have a special symbol for this, like intersect at 90 degrees angle. Perpendicular. It's a long word. That's why they prefer to just put this symbol instead of writing perpendicular every time. When slopes are negative reciprocals of each other. So if I consider slope of the first line and a slope of the second line, and if I change sign, it's -1 to +1 and flip it, looks like then indeed this will be a relationship between lines, slopes. See, this is pretty odd. And well, I guess my goal is just to introduce you with this. In later math classes, they actually do a little bit more to justify this. So let me try another exercise, 49, with those perpendicular lines. So let me again take these two equations and pull out slopes from them. So the first equation is 3y plus 4. So that's the one that I have here, 3y plus 4. And then I will need to isolate y. So I can isolate it on the right side by, first of all, subtracting x. Bring x up, subtracting 4, sorry. Bring 4 over to the left. And then I don't need to have a 3y, I just need 1y. So we'll divide them all by 3, just like that. Every side every term of my equation when I divide by 3, end up with x over 3 minus 4 over 3. And I can put y on the other side, on the left, so this way we better see that shape, right? Mx plus b, this slope formula. So what is going to be my slope? Well, what's multiplied by x? I mean, it's Alex. X is actually not multiplied by divided by 3. Yes, so you put 3 in denominator and then 1 will stay in numerator. So if you just divide by 3, it means you multiply by a reciprocal, which is 1/3. So I worked out this equation number 1, and I was able to find the slope. And then I will look at the second equation here. They gave us a -3 multiplied by x plus 7. So the slope of that one is a -3. Why -3? Well, because that's what's multiplied by x, right? So here's my first slope. Here's my slope number 2. Do you see that they're reciprocals? 1/3 and -3, right? You flip 1/3, you get 3. You flip 3, you get 1/3. And one of them must be positive and the other is negative. And that's why we call those lines as perpendicular. So what does this mean, lines perpendicular? Well, let me try to make a picture of this so we can better see what is going on, why they called perpendicular. You say, Alex, you already said they intersect at 90 degrees angle. Yes, exactly. That's why they called perpendicular. So let me graph both of them. Like this line, I can graph using the pair of points x, y. So if x is 0, then y is going to be 7, right? If I put 0 here instead of x, which is going to simply disappear. I love that number 0. The other number I like is 1. So if I put here in the first equation number 1, this is going to become -3 times 1 and plus 7. So I subtract 3 from 7, and this gives us 4. So this is the other point. So once I have 2 points, then I can plot these points like 7 on the y-axis. That's first one, 0, 7, right? And then 1, 4 is a little bit lower. So 1, 4 is probably someplace here. So our first line is right there. Connect these points like that. Well, second line is coming. I think I would rather use this equation. I would rather graph equation x is equal to 3 times y n plus 4. Why do I want to do this? Well, because this way I don't have any fractions. Notice if you try to graph the equation I produced to pull out my slope, I'll have to mess with fractions. And honestly, I don't want to do this. And how will be nicer to graph it? I think it'd be more convenient to use numbers instead of y because x is isolated. Please notice if you were to replace y with a 0, then you get right away that x is equal to 4. So you get first point, 4, 0. So I'm trying to show you a shortcut, but you don't have to follow it. You can just graph any way you like, as long as you calculated 2 points. But again, I recommend you, if say variable x is isolated, it's more convenient to use choices instead of letter y, because this way you will be able to get your x right away. So once again, I'm gonna use that same exact little equation. So I'm gonna replace my letter y now with a 1, And looks like here you have x is equal to 3 plus 4, which is 7. So here's another point. Okay, that's great. So let me make a picture of the line. Since I produce a table with 2 points, I just need to put them, those points, on the plane. I'll put them on the same plane, and then I will connect them. So notice that 4 is on the level, the same level as the previous point was, because it was also with a coordinate 4, right? So I want to be careful. I want to put these nicely so everyone can hopefully see what is going on. So I already have 1 point here, and the other point is x equal to 7 and y is equal to 1. So the other point will probably be someplace where 7, 1. 7 is for x and 1 is for y. So somewhere here, I guess, something like that. Right? So connecting these 2 points, I guess I need to be a little bit more careful because I got the other line, which is going to be something like this. Alex, what is going on? Why these lines are not perpendicular in your case? I don't know. I should be a little bit more careful. I need to double check all of my calculations, right? That's the point of this process. So let me double check, because I think if I connect it like that, so whatever point is, the lines are not very perpendicular. They have to have 90 degrees angle, but looks like they don't. So let me see. Let me double check how I made pictures of those 2 lines, because the second one should have a positive slope, and my second one looks like it's not. Actually, the first one should have a positive slope, right? The positive 1/3. So I think the first line is something that I have to be a little bit. Actually, no, second is negative, so first one should have positive. So let me double check. 4, 0. So I see, because I switched x and y. That's why I wasn't careful. Notice that I should have put table with x and y, and I put y and x. I don't know why I did this. So x is first, so x is 4, y is 0. So I can change this real quick. I was not careful. I need to put 4 instead of x, right? See, I switched these around. That's why. See what is going on. But actually, it is 1 point here, 4 for x, or someplace here, and 0 for y. And the other point is 7, 1. Okay, so I think 4 is here, and then 7, and then 1 is there. So let me see, there are too many points. Which ones do you select? Well, I think 4, 0 is someplace here, and 7, 1 is a little bit up here. So when I connect them, then I get, looks like, perpendicular line. You probably see why they don't want to graph, because once you start graphing, it gets a little bit more challenging, since you need to be very careful when you select the scale. But the message is, once lines are perpendicular, they intersect at 90 degrees angle. So you can put this little box in the corner like that. And that's our answer. So it looks like there are lots of questions related to the lines in here. And my goal was just to introduce you with the ideas. And the key idea was that equation of line that passes through the point and has a particular slope is in this form. And the other equation is right here. That's a usual answer for our exercises. And there are, of course, other pieces of information that's good to be familiar with, but I don't think we'll get very deeply into that story. So I'd like to take a little look at the next section. So we move on a little bit. I think we spent plenty of time with this, but this section 2.3 does have quite a bit of material. So the next section is dealing with word function. You probably heard such a word. I use it sometimes. So the question might be, what is the function? What does it mean to be a function or not to be a function? Because it turns out that some of the equations that we graph happen not to be functions. So let me see how nicely they describe functions here. Like in example 2, they relate two sets, one with the other. You can see it's circled in A. And they also say that the main, that's where we start, the first set is the main. And the second set composes so-called range. So that's where we end up after we send the elements from one set to the other. So those are standard names, the main and range for the relation. And this relation of two sets, so we relate in our elements such as 4 with 3, 6 with 5, 12 with 9, and this relation happens to be a function. Well, here's the example where we relate the two sets again, and we don't have a function. Like in the picture here, this is not a function because we related element 9 with two different elements at the same time. So it turns out if you have a function, then one element cannot be related to two. So the bad type of relationship is here and here. Let me get it a little bit more clear. So the last two arrows that point out from 9 that give us not a function. So that's the idea. So you can relate elements of your domain only to one element of range, and that's how we produce function. We also have a test for these. So when they talking about function, then they can check it by the making a picture. So function is that wiggly nice thing, and another function is going to be the second picture because of vertical line here. There's a vertical line, the green one, that intersects my graph at 3 places. So that's why it's not a function. And the reason it's not a function is the same as we just saw here. We actually have element x that is related to y, which is here. But at the same time, there is another relation of the same exact element x to say y2, and there is another relation of that x to y3. So from this graph, I can see that there's one point here, such as x is related to y. Then same x is also related to y1, actually to y2. And then the same exact x is related to y3. And that's not allowed. We can only relate that x to one element on the y-axis, but we related it to 3. So that's why it's not a function. And this is actually so-called a vertical line test to see if your graph presents a function or not. So if you intersect the graph of your relation with 3 or more places with a vertical line, this is it. we don't have a function, so that's our result. So functions or not functions, well, I guess we're not going to get very deeply into this story, but since we're talking about functions and we will talk about them from now and on, it's good to know what those functions are and what they're not. So let me go to the exercises in this section and do some problems here. Looks like today I'm not gonna give you a quiz, and that's, I guess, not a problem. I'll just do a couple of problems for you so you can see the ideas of being a function or not being a function here in the next section. So I'm on the page 171 for the quick access. And on that page 171, I can try exercise like number 29. And the answer is it's not a function. See, the nice thing of this textbook, you can see the answers right away. But of course, the question is, why not? And we producing a vertical line, we can find one vertical line that is intersecting our graph at 2 points. When you say, Alex, here's another vertical line, the y-axis. Yes, if you can find just one such a vertical line, this is it. It's not no longer a function that's done. So if you can find one vertical line that intersects at more than 1 point, then we don't have a function. Here they also tell you what domain is, and looks like domain is everything on the x-axis, because our function relates x-axis with y-axis, or sends numbers from the x-axis to numbers on the y-axis. And looks like in this particular case, all of the values on the x-axis up to 1 have some corresponding points on the graph of function. And if you try something greater than 1, then there is no function here. And that's why they say that domain is ending at 1. And notice they put a bracket, so it's included number 1. And of course, you probably guessed that R stands for the range. It's a friend of domain. And the range is always on the y-axis. Notice that entire y-axis works. So any point on the y-axis will eventually have some corresponding point on the graph. So that's why all real numbers or entire y-axis is in my so-called range. So similarly, I can do the next problem. I can see that there is a function in exercise 30, because no matter what vertical line I try to think of, it'll intersect my graph only once. So this will be a function then. So this function also has domain and the range. So I can see what those are. And when you say I can see it, there's an answer here. Yes. So domain is everything. So notice that for this function, any point on the x-axis, anything you can think of, you say, I take that one. Well, if you continue your graph, eventually you will see it's having a point on it that has that value x as its x coordinate. So any number is in domain. We can see this from the picture. And then on the range, I start with 1. Why do I start with 1? Well, because range is always on the y-axis, remember? So notice that the point here, the lowest point on my parabola, that sits at 1 on y-axis, and then everything else goes up higher. So above that point, or from 1 to infinity, we have various y coordinates of possible points on parabola. And below, well, there is no graph. That's why we cut it out at -1. So this is how we can do this. So let me do one more exercise from the next group, and that's probably going to be a good enough for today. So maybe then we can deal with you. Did I ask you to come over? Yeah. Okay. Good. Good. So that's great that you came in, so I can help you with some things that and no problem. So if you oh, that's no good. Definitely, if you had a car accident, that's no good. That's very disappointing. So I hope that you're not going to have one again. So, but anyways, so let me try one more exercise, and then we'll end it for today without a quiz. So let me try to do the problem number 41. Actually, this type of exercises is something people say favorite, because all you do is just plug the numbers in. So in exercise number 41, where you're given some kind of function, which is a absolute value of x minus 3, we have two values, f of 2 and f of minus 2, to find. In other words, I just need to replace these numbers +2 and -2 into my function. So I put, instead of letter x, number 2, just like that. So if I subtract 2 and 3, I will get the answer, which is -1. So it's just a calculation of functional value. And we already did it, like in a previous section, we utilized some numbers instead of x, like here I used 0, right? Then I used 1, and then I calculated what y was. Now instead of y, they put f of x, because they just want to declare that this is a function. Well, it doesn't matter. They do pretty much the same thing anyways. So what if I use -2 now? So I put it inside the absolute values. Well, absolute value of -2 is +2. So when I minus 3 from it, it's actually negative number 1. Just like that. So I guess I'm gonna end it for today, because I have someone in the classroom, so we can do a little bit of work related to the class. So I'm not giving a quiz. We'll have a quiz next time on Monday. So far we went all the way through the section that deals with functions, that's section 2.4. So as usual, you can do a few problems, and once you're done with this, that'd be great. In fact, you have a whole weekend in front of you to do these exercises, because again, all of the homework will be due on the day of the midterm, and I believe that'd be something like 20. So it will be on Wednesday. I believe it's 22nd or something, the February 22nd. So it's about 3 weeks from today. So we'll just keep working on chapter 2, and then we'll see what exactly sections will be covered before that midterm. So we'll discuss it in a very depth. And again, I want to remind you, if you're late for class, if you're supposed to miss the class, it's not a big deal to me. Make sure that you check the recording of the lecture. I record lectures, and I send you links to those video recordings, so you're aware what we did in class. And sometimes I give a quiz at the end of class, so you can just send me the answer to that quiz. Even if you missed the lecture, well, I will still accept the answer to that quiz. So this way I know that you are on the same page with everyone, that you don't get behind. That's main idea why I allow people to, well, send me the answer to the quiz a little later. I understand that sometimes things don't work and sometimes you have to miss a lecture or two or three. Well, then just check the recordings of lecture. That's why I send them to you by email every time after the class ended. A few hours after that, I send email with a recording of lecture. And that's what I'm going to do today as well. A little later today in the afternoon, I will send you a link to a recording of today's lecture. So that's important to realize, I guess. So I'm gonna stop to record and let you go and